All right, this is a screencast on logarithmic functions. So here we'll learn how to convert from logarithmic form to exponential form and exponential form to logarithmic form. But first, let's have a warm-up. So here it says, let's graph f of x equals 2 to the x, which we learned in our last unit, which was graphing exponential functions. So let's go ahead and graph that. Using points here, we can plug in -1 and know that we get a half. Plugging in 0, we get 1. Plugging 1, we get 2. Plugging in 2, we get 4. Plugging in 3, we get 8, so on and so forth. And we don't need that many points, but just to have a good idea. Is that 8? It is. Okay. Remember, we have a horizontal asymptote at y equals 0, so our graph follows along the asymptote, which I'm not going to end up drawing in, and it looks like so. Okay, so we graphed f of x equals 2 to the x. Now it says find f inverse of x and graph it on the same coordinate plane. So we know how to find an inverse. We know that we have to switch x and y. This is just a fancy way of saying y. So if we switch x and y, we have x equals 2 to the y. And then we have to solve for y. So the problem we have here is that we don't know how to solve for exponents. Okay, that is what we learned in this chapter, but we don't know how to do that. So we do know another way of how to graph inverses, and that is switching the x and y values. And we have a bunch of points, so let's just switch those. So we had -1, a half. So we can do, I have to write them down. I have to look, I can't switch them in my head. I get too lost. A half, -1. Then we have 0, 1, and we're going to graph 1, 0. And then we have 1, 2, and we can graph 2, 1. And then we had 2, 4, and we can graph 4, 2, and then 8, 3. All right, so what you should notice here is that this is following a similar pattern. This isn't following a vertical asymptote, it's not following a horizontal asymptote, but it's following a vertical asymptote at x equals 0. And it looks like so. Okay. So what is the significance of that line y equals x that's graphed right there? It's very slight, but this is the line y equals x. And you should see that it is the line of symmetry between the two graphs. So that is the line of symmetry. Or it's a reflection over that line. Is f inverse a function? So is my red graph, which I forgot to put an arrow on, is that a function? If you look, it does pass the vertical line test. If I draw a vertical line anywhere through that red graph, it does pass the vertical line test. So yes, it is. It is a function. What is the domain? What is the range? So if we're looking at that red graph right there, it has a vertical asymptote right here, and it is only graphed to the right of that. So all my values start at 0, and then they go on forever and ever and ever, but there are no values at 0. And then the range, the lowest it goes is an arrow pointing down, the highest it goes is an arrow pointing up, so -infinity to +infinity. If you notice this domain and range, that is the inverse of y equals 2 to the x. Y equals 2 to the x has a domain of all real numbers and a range of 0 to infinity, and it makes sense. All that we did was switch the x and y values. So what we'll learn in this unit is how to write this in its proper form and how we would graph it once we had that. Okay, but for now, using points is a good thing to see. Okay, so let's talk about logarithms. It says if b and y are positive numbers and b is not equal to 1, the logarithm of y with base b, or log base b of y, is denoted by log base b of y. So that's how you say this right here. Let me get my highlighter out. It says log base b of y, and it's written right here, right? So what we're going to do today is we're going to convert from logarithmic form, which is the form we just looked at, log base b of y, to exponential form, because logarithm and exponential functions are inverses of each other. So just like addition and subtraction are inverses, multiplication and division, squaring and square rooting, That's what logarithms and exponential functions are. Okay, so to convert from one form to the next, if you have log base b of y is equal to a number, right? Then that is true if and only if you can rewrite it in an exponential function where the base b is this base b here. Whatever the log is equal to is your exponent. And then this right here, which is called your argument, is equal to it when it's written in exponential form. So we're going to do some practice of rewriting from logarithmic form to exponential form and exponential form to logarithmic form, okay? So once again, if you know that, this is your base, your logarithm is equal to your exponent, and then this right here, which your argument is what it's equal to, you should be fine, okay? A couple things before we start. If you see a log right here with no base written, that's because the base is 10, okay? That is called our common log. If you see a logarithm written like this, you're like, it doesn't say log, it says ln. That's called natural log. Natural log has a base of e. So whenever you see natural log, just know that that is log with a base of e. Okay, so what we're going to do here is we are going to rewrite each equation in exponential form. So you should be able to pick it up from these first four, and then you can try the next three on your own. Okay, so this is in logarithmic form, and all we're doing here is rewriting an exponential form. So to rewrite an exponential form, you need your base. Your base is 4. Logarithms are equal to the exponents, so your answer is your exponent equals your argument, 64. And if you look, 4 to the third power is 64, and that's why log base 4 of 64 is equal to 3. Logarithms are exponents. This one here, your base is 6, your exponent is -1, equals your argument, 1/6. And that, once again, true. No base written here. Whenever there's no base, that's common log, so your base is 10 to the third power is equal to 1,000. Also, you can verify that these are true, which makes you feel good, and then you know you did it right. All right, go ahead and try these 4. Pause the video and try, these 3 on your own. All right, so let's see how you did. So here, this is natural log. Natural log has a base of e, so it's e to the 0 power equals 1. 7 to the first power equals 7. 5 cubed equals 125. And that's just rewriting in exponential form. All right, now this is vice versa. We're going to rewrite these in logarithmic forms. These are in exponential. We're going to write in logarithmic form. So I'm always going to start off by writing log and then writing down the base. Now, if the base is e, I'm just going to change it to natural log. So none of my examples do we have a base of e. All right, so we have log. The base of your exponential function is 2. And then your argument is what it's equal to, so of 8. Is equal to, and logs are equal to your exponents, 3. So log base 2 of 8 equals 3. This one right here, log, your base is 3 of y is equal to x. Okay. Next one right here, log base 16 of your arguments, what it's equal to, so 1/4. I'm going to put that in parentheses to make sure we know that it's the fraction 1/4 is equal to -1/2. And then lastly, log base root 5 of 25 is equal to 4. All right, go ahead and pause the video and try these 3 on your own. All right, this one right here, I go to write down log, but I notice that it's base e, right? So if I wrote down log base e of 1 equals 0. We don't write down log base e. There's a nicer way of writing it, so we just write natural log instead of 1 equals 0. This one here, log base 4 of 1 over 256 is equal to -4. And the last one, log base 2 of 32 is equal to 5. Okay. All right, so last thing we're going to do before you have some practice here is we are going to come up with our basic exponential rules, our basic log rules, okay? So we're going to discover something by exploration here. So what we're going to do is we're going to evaluate these 3 logs, okay? So we want to know what it's equal to. So whenever you're evaluating a log and you don't know what it is, like log base 5 of 1, what is that? You can rewrite it in an exponential form. So I can say this is 5, and then I don't know what this is. Like I can put a box here, I can put an X here, I can put whatever I want, but it's saying 5 to what power gives me 1, right? So 5 to what power gives you 1? That's 0. This one says 8 to what power gives me 1? 0. 1/3 to what power gives me 1? 0. So we can generalize something from doing these 3 problems. If you notice what they all have in common is they all have an argument of 1. So whenever you have a logarithm with an argument of 1, it's equal to 0. We can rewrite in exponential form to verify that it's true. So we have, if we rewrote this then in general form, we have b to the 0 is equal to 1, and anything to the 0 power is equal to 1. So that is true. Bing. So this is our first little rule here that we have, and that is, once again, if the argument is 1, that's equal to 0. Okay. Let's go ahead and look at the next one. We're going to evaluate these 3. Notice a pattern, generalize. So this is asking us 3 to what power gives us 3. This is asking us 5 to what power gives us 5. And this is asking us 1/2 to what power gives us 1/2. And those are all 1. So 1, 1, and 1. So what you should notice here is that the base and the argument match, right? Base matches argument, base matches argument, base matches argument. When you have your base and your argument matching, that's equivalent to 1. So log base b of b is equal to 1. We can rewrite it in exponential form. We can rewrite it in exponential form to verify it. So if we rewrote this in exponential form, that's b to the first power equals b, which is true. So that works out. So this is our, where'd my highlighter go? This is our second little rule we have here. Log base b of b is 1. Okay, so if the argument's 1, it's equal to 0. If the base and the argument match, it's equal to 1. And once again, if you ever forget those, you could write it like this and figure it out, but it's faster just to know when you see it. All right, next one right here, if I want to rewrite this in exponential form, because I don't know what it is, my base is 2. To what power gives me this? So 2 to the 3rd power. If I rewrite this one, my base 1/3 to what power gives me this? 1/3 to the 4th power. Put that one in parentheses too. This one, 7 to what power gives me this, which is 7 to the 10th power. So if we fill these in, like this obviously has to be a 3, this has to be a 4, this has to be a 10. So the answers don't have anything in common. It's just that if you look, what they all had in common in the first place is that they had a base and an argument in common again, right? So here's base and an argument, base and an argument, base and an argument. But they also had an exponent here, so it was equal to the exponent. So if you have a base and an argument that matches and it's raised to an exponent, it's going to end up being equivalent to that exponent. So b, log base b of b to the k power is equal to k. Once again, we'll rewrite this to verify that it's true. Our base is b, and then to this k power is equal to this right here, b to the k. b to the k is equal to b to the k. That is true. All right, what I have here for you next is I have some practice problems for you to try. So you can go ahead and pause the video and try these 12 practice problems, and then come back and check your answers and see how you did. All right, I'm hoping mine are still here. Paste, yes, they are. Okay, here are your answers so that you can check them. Let me just slide that in there. There we go. All right, here are the first 6. And here are the second 6. All right, that's it for our practice for today.